Welcome back. In this tutorial we are going to be creating a very powerful save game system, making use of good programming practices. If you are one of those people who have looked at save game tutorials and don't quite understand or can't go from that part to how you can make a usable system for your project or game, then this is the video for you. If you follow along to the end, you will have a very powerful save game system that can be applied to almost any project. The system will be super easy to maintain as well as to interact with. The save game system will be incredibly scalable and flexible. I will first go through how to make the system while adapting it to my existing bare bones project. Then I will show how you can extend and build upon this system further. Lastly, I go through the simple communication flows that we have and make use of in this to bring it all together. You do not want to miss this. Let's check it out. So here we are inside of the project that I will be using as sort of our foundation for our system. It doesn't have a whole lot of functionality in it. We have a main menu here where we can, for example, enter a level. Inside of this level we can see that it's numbered 1 on the floor because this is level 1, and we have a portal here which leads us to level 2. When in level 2 we can move to level 3, and from level 3 we can move back to level 1. So we have these different maps available to us, and in addition to that we also have this in-game menu we can bring up. This is some debug data. It's going to be of interest later, but not for now. In here we have resume, save game and quit. So I was thinking we can create this system by starting at the execution flow of where the logic would begin, which in this case will be the save game, and see how we reason our way forward from there and onwards, basically. So let's open up our in-game menu. Our in-game menu is a very simple widget here, and I have a little bit of code here. I have a quit button which quits, and we have a resume button which removes the widget from the parent, and then we have a save game button here which we're going to be hooking in our logic to. So the requirement here is what's going to be dictating how our game is going to be working, and by that means how our save is going to be working. That is how most software development works. So our specific needs will sort of tailor our solution to it. So the idea here is that we have this game, and we want to have a system that's flexible and it's scalable and it's easy to use and just very manageable overall while being modular. So we want to have like certain points where different parts of code will say that we should save the game now for some reason. This could be something like we pressing the menu and saving out to quit the game. It could be something like traveling to a different level. It could be something like going up to a save point, something like that. Something that can trigger a situation saying, now we want to save the game. So that's where we will be like starting off our logic from. So in our in-game menu, this is what we want to do over here. So we excuse me. So we want to have a save function now that's easily reachable from many different places. So inside the Unreal Engine architecture we have something called the game instance. Now the game instance is a class that exists throughout the lifespan of your gaming session, so it persists even if you travel between levels and such. So it's a fairly key and core part of the classes that are available in the framework, and allows us to actually make some communication with the save game fairly easy. And that's where we will be starting. Now you will not be having the same project as I have, but that doesn't really matter. If you follow along, you'll be able to recreate this system just fine, and you'll be able to hook it in to basically any kind of system you want, regardless of how you want to save the information. It all depends on how you want to make use of it, but I'll be going through a bunch of different examples and such. But anyway, in this project I have a save folder. Inside of that we're going to be creating this first class. We're going to be having a game instance. So we'll select one of that, dp game instance. So the game instance here is our own class of the game instance that we want to have some communication with our save game. So let's start off with also creating a save game class for us. So type in save game, and we can call that just bp_save game. Now, the save game class, we can leave blank for now, basically. We just want to have it available inside of our game instance. So we'll create a variable, make it of the type bp game, bp save game. We can call this the save game reference, like so. So this is the class that we want to communicate with. And we want to do this in this manner because of a few different reasons. The game instance is easily obtainable from many different locations, which suits our needs and requirements. And it can also persist the save game object throughout level transitions and such. So inside of the game instance, we want to add some basic functionality to be able to manipulate towards this save game. So we are going to be creating a custom event to begin with, which will be our event which we save the game with. We'll be calling it save game. So this will be our saving event. And we're going to be making it in the event graph because this might be something that we're doing asynchronously. So we'll take that in as a parameter as well. So we add a boolean called async. And this will be deciding if we will be doing a save that's asynchronous or not. So we'll take a branch from here and we'll just hook that up. And then on the true, we will be saying that we want to take our save game reference and we want to do an async save game to slot and hook that up to true. And then once we go to false, we want to do a save game to slot. We'll promote the slot name to something called maybe save game slot name, something like that, descriptive. We'll compile and we'll give it some default name just so we have something assigned here. So slot 1 is what I'm going to be making use of for now. We're going to be making sure that we have this parameter sent in over here as well. So now we have the two different cases here where someone is calling on this event wanting to save asynchronous or synchronous. Asynchronous meaning that it will not run on the game thread, so it will not stop the game, it will continue to play the game. So you might want to have something like a widget playing that shows that it's working until it's completed. We will not be adding that here, but it's easy to add if you wanted to. The synchronous save game might be something that you're using in situations where, for example, you want to leave to another level. There's no point in making it an asynchronous call because that's the point where you just want to make sure that you're saving the game as quickly as possible so you can crash that level and start up the new level essentially. So these are the two cases that we have. And once we are done here, we essentially want to possibly notify someone that we are done with our saves. So we'll create a event dispatcher. We'll call this actually, let's call it game saved. So game saved, we will be adding a variable form and it will be of the type bp save game because there might be situations where whoever is listening to this call is interested in the save game data as well, and we will be making use of this later as well. So dragging this out, we do a call. We'll go back to this and actually name it to something better. So we call it save game ref again. And compile and refresh this node so it gets its name updated. And we hook up the completed to this. So we're going to say that we're completed. On the completed event is when we're actually saying that we're done with our saving. And the save game reference here is going to be this reference over here. We're going to do the same thing over here. And we're going to be calling it like so. So at this point we have a function that we can say save game, choose asynchronous or not, and it will tell us when it's done after it has actually done the save. This is wrong. This should be in the save game object. If we do it like this, maybe. I don't want to have that async save slot. So we'll get rid of the world context there, make it a little bit cleaner. Like so. And hook it up to the completed. Alright, so now we have the situation where we could theoretically save the game to a file on the hard drive, right? But we're missing one step. We can save the file, but we haven't actually updated any information. So what we want to go ahead and do is something like creating a blueprint interface. So we'll call this bp_persistence. And we'll add a function called here request save. So in this one, we'll also say that we're going to send a sync parameter. So this will be the method that whoever wants to save is going to be calling upon, and it's going to be specifying if it wants it to be asynchronous or not. In our game instance, we want to implement this interface. So BPI interface, persistence, sorry. I did not name this properly, so we're gonna rename it quickly. Like so. So that allows us to have the interface event here, which is called request save. So request save is a request from something, but it doesn't necessarily mean that we will be saving. That you can put logic here to actually decide not to save if there's like, I don't know, maybe the character is in combat or something like that. It's completely up to you if you want to add validations to this. What we want to do at this point is we want to start communicating with I'm gonna skip any kind of validations like what I just mentioned. I'm just gonna start communicating towards my save game now. So what I want to do is I wanted to say to the save game, I want it to have all the information updated for this save game. And how we're gonna be doing that is a little bit clean here, in my opinion. We're going to be creating a list of objects which are of relevance for the game save. So to do that, first we will be creating another interface, and we'll be calling it BPI_savable. So this will be something that's related to everything that is a savable object in the world. So on the request save, we're going to be saying get all actors with interface. Now this is something that I don't normally make use of, but a save is not something that you do very often, so this is fairly fine. BPI savable is what we want to have as that interface, and now we get a result of actors. This result of actors is something that we want to pass to our save game object. Our save game object can't get this information itself, so the game instance is getting it for us. But we want to create a method inside of the save game, which then makes use of this information. So we'll go to our save game. I don't have it open, it seems. So here we go. Create a function. We can call this save all data. Like so, and we can say that it wants to take in an array of objects, like so. We can call these savable objects. So going back to our game instance again now, we can go to our save game reference here, and we can say save all data, and we'll hook that up and send in the information we just gathered about all the objects that are tagged as savable through the use of this interface. Now, once we are done with this, we will consider ourselves having updated the save game object over here with the the latest information. So at this point, we can actually go ahead and say we want to save the game. So we'll be calling save the game over here, and we'll be hooking up the asynchronous flag like so. So now we just need to do the logic of how do we actually update this information then, right? So we go to our save all data function. Inside of save all data, we're going to be going ahead and doing this pretty simple. We're going to be doing a for each loop, and then we're going to be saying we want to call on all of these and we want to say save data. We don't have such a method right now. If we go into our savable interface, we can create one called save data. And as an input, it will be taking a BP save game. So what we're doing here is essentially sending, let's name it something better, save game ref. So we're saying to all of these different objects that are holding some kind of information that's relevant for our save game to get a copy or a reference to the save game object so that they can fill in their information for us. So we're essentially just handing out a map to different parts where we tell them, come over here, fill in your data, and once you're done, we're happy, essentially. So in our save game, we're going to be calling this save data. And the save game reference that it wants to have here is, of course, the object itself that's working through this process. And then once we're done with that, we actually return and we're done. So it's not more complicated than that, actually. Like so. So how do all of these things come together now? Well, if we go to our in-game menu here now that had the save game button, what we want to do here is we want to cast to our BP game instance. And the reason for this is because we want to have access to the event dispatcher that we created earlier. So we want to bind to game saved, like so. And this is the event that we want to hook it up to, although this is not, sorry, like so. We want to add an event because we actually have a parameter here. So we get the save game reference here that we defined. We'll call this saving completed, like so. And then we say that we just want to close down the menu, in this case, the UI that we have, essentially. You could have other logic here, of course. It all depends on what you're going for. But this essentially says that since we're running this, that's all that it's going to be doing. In addition to this, we also want to tell it that we want to save. So we call the request save. There we go. And we want to specify if it's asynchronous or not. And since this is being done from a menu, you may not want it to be cutting off all of the performance, so you might want to have this as asynchronous. So now we have the first functionality of actually saving information. When we press the save button, it's going to be saying, okay, call the game instance, and we bind our event to say that, okay, once it tells us that the game is saved, we will be running this code, and after that we execute the actual request to save the game. In the request to save the game, we get all the actors with this interface, which currently is none because we haven't set that up yet, and then we say save all data on the save game object. This in turn will call to all of those and say, this is me, I'm this save game object reference, fill any data that you want to have. And once that is done, we are back here and we can actually save down the file to the hard drive, which will now be updated with the latest information. So how does this look then? Well, if we take something like our third-person character over here, I have created a variable called gold. So this gold value is something that we want to save to this file, let's say. What we do is we want to implement the interface that says it is savable, because this allows this interface to show up in our get all actors method. Inside of this we have one method here. We implement it, and this is our key part where we actually fill any information here. So our save game currently do not have any variables to store any data inside of it. So we will be adding that. So let's add something like gold, and let's have it of the integer so it matches the other thing. How you want to structure your data here, if you want to have a bunch of it in structures, to have it organized in certain ways like player information, etc, and arrays and such, it's completely up to you. I'm just keeping this simple so that you can follow along, that it's very easy to expand upon this. In this case, we have now a gold variable inside of our save game. So if we go to our third-person character, we can say set gold, and we can say that the gold that it's going to be setting the value to is the gold that we currently have on our character, and that's all it does. So this is the population part. So when the save game sends out these pings to all of these actors that have the interface that are savable, they will be filling in their data, sort of like they have been given a sheet to fill in, a form to fill in, and then they're done essentially. So that's all that they're going to be doing there. However, savable also means that we want to be loading something. So let's add a load function, since we're already here, and this is very relevant to this. And again, we're going to be sending in a save game ref of the same BP save game type. Going back to our third-person character, adding the load event here, we're essentially going to be doing the same thing but in reverse. So from here we're going to be getting gold, and we're going to be setting our gold to be that value. So in one part we're saving it to the save game file, from one we're loading it or reading it and setting it to our character. Okay, so far so good. Now, you can't save to the hard drive if you actually don't have the save game created yet. So for me in this example, I have a main menu where I have a button which says new game. This makes for a pretty logical place for me to say something like, okay, well at this point we're starting a completely fresh run, so we're going to be creating a new save game so that we're going to be tracking all our data in that save game. So when we shut down, that's where we have it. So in this button currently all we're doing is we're opening our level 1. Now we want to add some functionality to actually create a game. So we're going to be casting to our BP game instance, and then we want to have a function there which allows us to create our save game object. So going to our game instance, we're going to be, let's go up a little bit, I guess, and do a custom event. And let's call this create save game. Inside of this, we want to say we want to create save game object of the type BP save game. Now that we've created it, we can promote it to a variable, and we have that variable over here. So we'll set it like so. So in this case, when I press main menu, start a new game, then it's going to create this save game object. So we don't have a null reference when we're trying to do something like saving to it later on. Okay, we are starting to get some pieces to come together here now. However, we don't actually make use of anything we're saving right now. So let's actually start working on actually loading up information as well, because if we go and save the data, that's not gonna be helping us a lot for displaying it. So let's add some functionality for that. So inside our game instance, we'll be adding a further information here. Now, one of the things we want to have is probably a point where you want to have a request for load information, the same as we had one for save information. So inside of our, let's see here, save folder, we have the BPI persistence, we have a request save. Let's add a request load as well. Now the request load will be something that's sent from a specific actor or object or something. So it says that I want to have my my save game information so I can load it into my variables. So what we will be sending as a parameter here is actually going to be an object. So an object reference, and we can call this the requester. So inside of our game instance, we have now request load. So our request load will be handling whatever object is telling us that it wants to have its information. We will more or less just be sending this further down into our save game and let it handle it. So we'll create something like loading requested and have it as an object of single variable requester. Inside our game instance, we'll just be calling, using our save game reference, loading requested. So it's up to the save game to deal with whatever is going to be needed to be done there. Inside of save game, we're not going to be doing much. We're just going to be taking this and saying load game, nope, load, what did we call it? It's part of the savable, load data. Let's see, game instance, there, no, save game, load data. So this will be the information. Also here we'll be sending in our reference to ourselves, like so, and return from that. So now we're essentially getting a ping from a object saying that it wants to have its information. So we're sending a reference of ourselves to them so they can unpack it essentially. So that's what's happening in our third person character. It gets the this event that it can pick its gold from and set its variable to. But now you get the problem of, well, when do we request data? Since in Unreal Engine, you have different classes that are going to be constructed at different points in time. Also, other reasons might cause objects to be called at different points in time. So what you do here is you have an event which requests for the loading of the data when it makes sense. In this case, we can say that when our character is being constructed, so the begin play, it is logical that that is the point when we want to make sure that it has its information. So if we say get game instance, and we say request load, and the requester in this case is of course going to be a reference to ourselves, like so. This will be saying to the game instance that we want to have load information. The game instance will then be saying, okay, send that to the save game. Save game will be saying, okay, well, here's a reference of me. And then you come back to the third person character with this interface call here, which you can then get this information. So you don't get this problem of like having to wait for certain objects to be done or something of that nature. Each object will be responsible for itself for requesting a load and a save depending on what its functionality is going to be. So in this case we have very few things that can actually say that we should be saving things, but everything that's relevant for holding information will be requesting a load, sending a load request to the game instance. So now we need to actually read this information from the database. Actually, I'm not super happy about this name. Let's change the loading request. Let's change it to load data for requester, maybe. That feels a little bit better. Anyway, so in our game instance, we need to add information so we can actually read a save game file from the hard drive. So we'll get ourselves some space up here, maybe. We'll create a custom event. We can call this one load game, like so. And in my case, I have a main menu here where I have, let me demonstrate, I have a new game and a continue. In this case, you may not want to have the continue to be clickable if you don't have an active save game available. In my case, I don't have any such validation, so I have to go in and make sure that I actually check that first. So does save game exist is something I need to do to make sure that I don't try to reference a object that doesn't exist right now. And it will be making use of the same save game slot that we have defined earlier. Based on this, we will be taking one of two directions here. One is that we do not have a save game slot. In that case, we don't want to do anything because the continue button will be what calls this essentially. So at that point, we're doing nothing. When it comes to the true part, however, we do want to do something. And what we want to do is we want to make the determination if this is going to be an asynchronous or synchronous load, just like we had for the save. So let's add a parameter here of the type boolean and call it async. And let's do another branch and then check against this async like so. So now that we know if we're going to do an asynchronous load or not, we can call those specific values. So we get our save game reference. So the top one here is async load. Hold on. Am I remembering wrong? Load async slot. What's a load game from slot? I must have typed something wrong. I don't know. Anyway, so we go in here. So here we're doing async, and down here we want to do a load game from slot. That's not asynchronous. For the same reasons that we had before. Some of the time you may want to stop the game and have it like focus on what it's supposed to be doing. Sometimes you might not. This gives you the flexibility to do so. It's probably because I used this one to hook up. Anyway, so the save game slot here we're using are the same, like so. Now we have our two different parts here. What we want to do now is when we do a load, we get a base version of the same game, and that is not what we have here. So we can't save it like a reference. So we will be having to cast this to our BP save game. We'll do that up here as well on the completed. And then we set that this is the game that we're currently working with, so we have all the information saved for later if we need it, right? In addition to this, just like we did for the save game, we may want to inform anyone who is interested to be notified that we have actually loaded the game. So let's create an event dispatcher called game loaded. And we'll add a parameter of the type BP save game again, because again, they might be interested in the information that's in the save game. Save game ref and compile. And let's call that on both of these situations. So one, we have done the asynchronous one and the synchronous one. We both let people know that we're done. Save game reference over here is going to be this one, which we just saved over here. Could have just hooked it up like so, of course. Okay. So now we theoretically have the ability to load in a file as well. Let's see if we can make all of this come together now. Going way back to our main menu again, we're actually going to be adding the create save game that we created earlier. We didn't actually make use of that. So now we have that one here, and we can actually continue to open our level afterwards. Now, we have created a game instance, but we're not making use of it, so we need to make sure that we actually make use of it. So we go to project settings and maps and modes, and you replace the game instance with the one that you have created. In our case, BP game instance. So now that we have our game instance here, we're actually ready to like play around with this a little bit. So to be able to save, we have our save game in-game menu that we created a button for and have some code for. To load, we need to have our continue button in the main menu that I created. So inside of the main menu, we have the continue button. Like before, we need to have a game instance. We can cast this to our BP game instance. And we can call on that and say load game. If we need to, which we will be doing later, we will be listening to our event as well, so we know when to load the information. Actually, let's do that at once. So we'll do a bind game loaded, like so. Let's try to do this a little bit better. Like so. So there's nothing more than this essentially. So we add our event as well over here. Saying the game load completed, game load complete. That's fine on me. That's a fine name. And then we can say open a level. Let's do an open level by object reference. We don't care about which level for now. So we'll just do level 1, like so. Okay. And this one I've chosen to do asynchronous, well, not synchronous, not asynchronous. Shouldn't make much of a difference in this case, but you have the option at least. So let's demonstrate this a little bit quickly now then. So we have our main menu here. We run it like so. We press a new game. We will be creating a new game. We can go to our third-person character over here. We can see that the gold here, I have made it instance editable so we can see how much it has. So we have 0 gold at this point. And if we transition to a different level, you can see we still have 0 gold. And if we were to restart, it would remain so. I have, however, put in a debug key here. So if I press that debug key, we can see that it goes from 0 to 42. So now we have 42 here, but nothing has been saved. But if we go to the save game menu, now we have run the save game code. If we were to close this now and run again and press continue, we should theoretically be loading up 42 gold. So we can see that it actually saved it and loaded it up properly. So that's a good first start. I forgot to demonstrate. If we run again and press continue, character, we can see 42 gold. We can also see that if we change levels and go to our character, we can still see that it has 42. And the reason for this is like what we talked about earlier. The third person character on its creation will be calling the, if I can find it there, the request for load, which will be getting the save game data, and it will unpack it and set its gold to be its value. So every time it does a level transition, it actually updates its information automatically by this means. I'll be going through a more detailed summary and some flows so you can get a better understanding for how the system works in a bit, but before that I want to first spend some time showing how easy it is to expand upon this system. So let's say we want to add some save game data. So let's say our third person character here doesn't only have gold, it also has silver. So we add a variable to our character, so now we have silver here, okay? Then we need to be able to save that to our save game, so we go to our save game, we have a variable there, call it silver. Okay, now we have that. What do we need to do else? Well, we need to make sure that it's populated. Okay, so we go to our third person character, make sure that our population events are making use of this. So we take the save game reference, set silver, and we hook that up, if we are able to, and silver. Okay. I should really get electronic notes. Anyway, so now we're setting silver. Let's read out silver as well. So we get silver from the save game. We set our character's value to be that value, like so. And that's all. That's all you need to do to add like one more parameter to your save game. It doesn't require any more than this. It's so flexible and easy to do it because there's so few places that are actually being changed because everything else is so dynamic. To display that this works, we can do a test. We can do something like setting our silver on our character. Let's say that we want to have this and we want to have 999 silver. So we go and start a test run, we do a new game, we go and click our character, we see that we have, let's make it instance editable so we can actually see it as well. There we go. Like so. Okay, so, new game, character, money, broke. Alright, let's fix that. Debug key, bam, 999 silver. Let's do something fancy with it. Let's save, let's quit, let's play, let's continue. Third person character, 999 silver. So that's how easy it is to do something like that. So, but that's the easy version. What's the hard version? What's the most complex situation? Well, it depends a little bit on what you're actually going to be saving, but let's say that we have, in addition to this information on our character, we also have a component called attributes. In the case of our game instance getting information for our save game, let's see if I can find it here for you. We get all the actors with interface. That only gets actors. Acting components are not going to be found. So to find something like a component on a specific actor, we have to, in this case, like a third-person character, the third-person character needs to implement the interface, and then it needs to funnel it forward to our attributes. So if we do something like, let's see here, we'll do we'll get, first of all, we can do this. We can go into our attributes. You can see that we have a value here called health. It's 42 by default. If we go back to our third-person character, on the event when it gets an information to say that we need to save data, we need to inform the blueprint component as well, right? So the blueprint component, we need to make sure that it has the interface. So we add the interface, make it savable, like so. It gets its functions. And inside of the third-person character, we then say save data. Like so. And the save game reference is the same one that we have over here. So we're just funneling it forward essentially. But we might have multiple components. We may not want to do this for all of them. So what we could do is we could get components by interface. And we can say that we only want to get the ones that are savable, for example. And we can, and this is the case if you might have a lot of components, of course, which you may not, but I'm just showing it so you have the reference of what you want to do. So we loop through that, like so, and loop body over there, array element. Let's remove this one and say save data is what I'm trying to remember. There we go. Like so. So now we get a possible wider range of components that all needs to have this information. And only the ones that are interested are going to be getting this call, right? So we're going to our BPC attributes. We get these two methods we need to fill in. And it's the same thing as before. We need to make sure that our save game has the information. So we add health. It is of the type float. We save, we go back. We say we want to get health in the load, and we want to set our health to be whatever that is. And we want to set health in the save and set that to whatever we do have currently in our component. Right? So in our third-person character, we can also add some debugging for this. We can say that we want to get this, and we want to set health to be, I don't know, 1, 2, 3, 4. So this would symbolize these being changed during runtime. So let's test this out. We go to our main menu, we play, we do new game. We go to our third-person character, we find our attributes, we find our health. It's 42, that's not correct. That's the default value, that should have been overwritten. All right, again, we need to make sure that we tell the system also when we want to have information loaded. So when we are created, get instance, get game instance. We want to tell it that now is the time we want to load information. So we do a load request. So, and the requester is going to be, as always, self. And then once the save game gets the information about this, it will send the data to us and we'll get this event and we'll set the health. So let's see if that works. We press play, new game, third-person character. Attributes, it's at 0, excellent. I press 2, it gets set to 1, 2, 3, 4. Excellent. So now if we go and press save game, and we quit, and we play, and we continue, and we check our character and attributes, and we can see that our health is maintained. So that's the worst case. That's the steps that you need to do if you want to add something like a completely different class that has information that's relevant for the save game. So it's essentially just a few more steps. You need to add the interface, you need to add the methods for the load request, the save data and the load data, and you need to add the information that's relevant for all of them, which is in the case here, it was the health, and we added to both this and to the save game. And then everything else works. It's so flexible for you. Anyway, this is the system in a nutshell. Now let's dive into actually explaining it a little bit more in detail. So if you had trouble following along, I made some charts for you to do. If you at this point understand everything, then of course you can just stop watching. You're pretty much done at this point. But for those that want a little bit more in-depth explanation of how it works, I'll take care of that now. So there is one final thing I want to fix as well and show you why it's happening. If we play and demonstrate, we can see here we have a new game. We go and we can go to our character. We see that we currently have 0 gold. If we, by debugging, add 75 gold and assume that this is what we accumulated during this level and then leave to another level in this case, we can go check our character and see that it has been erased. The reason for this is that we're not actually saving when we're leaving the level. We need to have another save game event when that happens. And in this case, I have a blueprint that lets us move to this different level. And here's that. We have a component that does an overlap check. We check if it's the player character in this case, that he is overlapping with the component, and then we're moving to a different level. Now we need to expand upon this a little bit. First off, we need to take a game instance and we're going to cast it to our game instance that we created. The reason for this is that we need access to the binds, the events that we created, the event dispatchers. So we will be binding here on save game, or game saved rather. Doing it like so, we can add an event over here. So now we have an event that we can call save completed or something of that nature. And then we can say that we want to open our level once we're actually done with the saving. And from the game instance we can also call request save. We would like to do that through the request save through the interface. Like so. And in this case we want to do it synchronously because we just want to save all the data and move on because we're leaving the level. Once it is saved completely, then we can say that we want to open a level because then we have all the data that's going to be relevant. So let's try this again and see what happens. So we play a new game. We have 0 gold. We give ourselves 75 gold. We move out here. We check, we have 75 gold. Now this also has acted like a normal save, like if we had gone to our menu, which means that if we start playing this and do a continue, we will actually be having this gold as well. So yeah, that's the little detail I want to make sure that you're understanding as well. Okay, so here we have the basic examples that I used in this case. In my case, I have a start new game button. In that case, I call the game instance and I say that I want to create the blueprint for save game. And then it opens the first level. That's the whole flow for the new game part. The continue part calls the game instance and says it wants to open a level from a specific save. We didn't go through that in this case, but we do the loading from the file, in this case, on the game instance. So that's the two basic menu flows. Now, saving, pretty simple. In this case, we have an object. It could be like the menu, it could be something like traveling levels, it could be something like a save point. They at some point want to tell the game instance that they are requesting a save. The game instance itself, it finds all the actors with the interface that are savable. It then calls the save game class or the object with that information that it found. It in turn will go through all of those different objects that it got and say, you should be updating me with the information that you have that is of relevance, because they have the interface, so they are marked as someone that has information that we want to save to the save game file. Then after that is done, it calls the game instance, and it says save the file, the save game, to the hard drive, and then it's done. So this is the whole flow for saving. It's not more complex than that. It's very simple. When it comes to the loading, it's fairly similar. An object that wants to know its save game data will be reporting at some point that it wants that information. Since objects are created at different points in time, a begin play might be a usable and good place to have that information so that it gets updated at creation. So on begin play, it will call the game instance and say, I want to load my information. It will say to the save game object that someone has requested some information. The save game will say to that object, well, here I am, read any information that you want from me, and that's all. So those are the simple steps that this system consists of. It's very simple, it's very scalable, it's very easy to maintain. It should be a very powerful tool and system for you to make use of. Anyway, I hope that this was valuable and useful for you. Keep on learning. Take care. A big thank you to all of you who like, comment, subscribe and share my videos, or through other means support this channel. You are what makes this channel grow and become a resource for other people to learn from.